let's look at the electrophilic addition reaction with H2. Now, when you have this reaction with H2, okay, do remember the catalyst is going to be, what is the catalyst? Let me check. Davis, what is the catalyst? 140 degrees with what catalyst?
Nickel.
Yeah, very good. Okay, nickel catalyst. Okay, so this one, okay, if you have carbon-carbon double bond, okay, so I'm taking this example. I'm not drawing all the hydrogen, okay. So if I have hydrogen coming in, you can just represent them like this. Do remember, okay, hydrogen, they are non-polar, okay. So when they come near to the double bond, okay, when they come near to the double bond, there is more electron. So the electron, they will push the electrons in the hydrogen so that they go further away. Okay, that's the only way to explain about the partial negative and partial positive. So since the electron goes further away, so you will have partial negative, partial positive, and some kind of fission will happen, but you do not need to show this. Okay, basically you are going to get H plus and H negative. Okay, you are going to get this. Okay, so one of it will become the electrophile, another one, okay, will react later. So the electrophile over here is going to be the positive, yeah, the positive H plus, okay, they are going to be attracted towards the double bond. But when you draw, okay, please be very, very careful, okay, because you need to draw the curly arrow diagram, okay, to show the movement of electron. Okay, so from the double bond go to positive. So what happens, okay, the this one bond will form a bond with the H, and then what will happen to the next? This will remain positive. Okay, it will remain positive, available for bonding. So next is going to be this H minus. Okay, you can rewrite it again, or you can use the same diagram, doesn't matter. Okay, but in this case, I'm going to rewrite it again. So H dot dot minus. Okay, so the one here, yeah. So I'm going to go and put it here. Okay, you will go there. So again, you look at the curly arrow diagram, it is moving towards the positive. It means the electron is at the H minus. Okay, do remember heterolytic fission is happening. So in this case, H minus is actually a nucleophile. Okay, it's actually a nucleophile. So anyway, okay, I'll just tell you what will happen next. Okay, it's going to be you are going to get CCH. Okay, no need to write. Okay, I'm just putting like this. I'm just putting it in this way so that easier to see. So you are going to get this. Okay, they are, okay, if you want to write down, there are how many steps? Maybe you can represent them in 3 steps, 2 steps actually. Okay, but depends on how you look at it. Okay, I'm just going to circle here. Any question?
Sir, why is the C positive?
Why the C positive? Because the moment, okay, the moment that you form a bond, okay, here, like for example, here used to have electrons, okay, they used to have electrons. The moment they form a bond, okay, it means that the carbon, the electron that was shared as pi bond is forming a bond to the hydrogen. So it means it will look like as though it has lost electron. So if they lost electron, so they are lack of electron, Josh. It means the double bond is losing the electron. So it is not stable. So this is what we call as carbocation. We have done this earlier. Later, I will give you some examples on this carbocation, because what will happen, okay, if I have different number of carbon, okay, later I show you, okay, there are different situations, okay, where you need to consider certain things, okay, but here it will form positive because the moment the double bond is broken, okay, to form new bond, it will be the electron, okay, is going to go towards the C and H bond. So the electron that was forming the double bond now is no longer there. So the carbon will become positive. Okay. So next, okay, if this example, okay, I try to use, okay, for Br2, you can use the same mechanism. Just replace the H with Br and Br. It's the same thing. Okay. The condition, okay, Br2 is going to be aqueous, okay, and then room temperature. RT is room temperature. That's it. Okay, just replace the H with Br. Okay, that's it. Now I'm going to show you, okay, with another situation where you are going to do addition with HBr. And this is going to happen under concentrated condition and room temperature. Okay, so this one will be slightly different because HBr, HCl, and HI, they are polar. If they are polar, okay, they do not need to come near to the double bond for having the partial negative and partial positive, because they themselves, they are polar. So because the Br is more electronegative, what is electronegativity? Electronegativity is the ability of the element to pull the bonded pair of electron to itself. Okay, please remember this. Okay, the term electronegativity, the bonded pair of electron to itself. So you see the bonded pair of electron will be pulled closer towards Br. Okay, so this is automatically going to become delta positive and delta negative. But just now, okay, the difference is they are non-polar. Okay, so they need to come near to this alkene, and then that presence of electron will repel the electron towards one side. Okay, so that's the difference over here. Okay, so here, okay, here you are going to again have heterolytic fission. You are going to get this H plus and then Br minus dot dot. Okay, you are going to get this. So what is going to happen next? Okay, do remember the first curly arrow has been drawn. Okay, so the next step that we need to put is going to be just put like this. So you are going to have H plus. So the H plus is going to be the electrophile. So they are going to go, the electron will go from here to here, and they will form a bond. Okay, so you are going to get C, C. Okay, so the one bond is broken to form a bond with H, and because lack of electron, because the electron went to the H to form the bond, okay, therefore this one is going to be positive. So after that you have the Br minus. Okay, now the Br minus will go here, forming CCH, H, Br, and H. Okay, you are going to get this condition. Okay, now you can use the same situation when you are reacting with steam, which is going to be with the presence of H3PO4, 330 degrees Celsius, 6 megapascal. Remember, memorize, yeah? So here, okay, if I want to show with HOH, okay, the way that we show is going to be the same. The H stays, okay, so the Br you change it to OH. That's it. Okay, so the remaining steps are the same. Okay, I'm sure that I do not need to draw this again for you. Okay, you just need to change. Okay, so this with that, okay, you can see we have done all the four mechanism, okay, involving the electrophilic addition. Okay, so to answer the question that Josh was asking yesterday, how the electrophiles are formed. Okay, the electrophiles can be formed in two ways. Okay, one, if you are non-polar, you come closer to this alkene, then there will be repulsion of the electrons, making it partially negative and partially positive. That's one. Another reason, another way the electrophiles can be formed is going to be having a polar molecules. Okay, they themselves will the electronegativity will pull the electron to one side, and then the heterolytic fission will happen. Okay, so this is going to be another reason, okay, or on how electrophiles can be formed. Okay, now I told you that I want to discuss about one more thing. Okay, let us discuss this. Yeah, so here, if I have CH3, Okay, let me draw. If I have C double bond C, and then I have H over here, H over here, H over here. But this side, I don't have H. Okay, I'm going to have CH3 for a difference. Okay, for example. Now, if I react this with HBr, okay, when I react this with HBr, there are two situations or two products that might be formed. Okay, I'll show you. One product will be HCH3, where the H comes here, and then the Br goes here. That is one situation. Another situation is going to be you are going to have C, C, H, CH3, H, and H. Instead of coming over under here, so the H goes here, and the Br goes here. And you can see that both of these molecules, they are different. Okay. Now, my question is, which one will be formed? Which one do we select? Okay. Now, even though there is a mixture of products will be formed, okay, there is one concept what we call as major product and minor product. It means the number of products that you, even though it's a mixture, okay, there will be one product that will be more compared to the others, compared to the other. Okay, there will be one product. And how do we predict that? Okay, so to answer that, you need to go into this carbocation concept. Okay, now I'll show you the mechanism of this reaction first. Okay, you see, C double bond C, H, 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 CH3. If let's say I want to form this, okay, what happens is the H, okay, the H plus, okay, H plus and the Br minus, okay. So the H plus goes here, okay. So I put H, CH3, H came here, CH, H, this is positive. I'll just stop over here. I don't want to continue. Okay, so it means the Br will go and attack this part. Yeah, okay, come and attack here. So I don't want to write down that first. Okay, I just want to stop over here. Now, if I have this, okay, C double bond C H H, and then H CH3, and then I have again H plus and Br minus over here. So instead of going to the left, okay, I put the H plus, the electrophile goes to the right. So I put CH, CH3, CH, H, H. Now this is going to become plus. And after that, the Br will come over here, okay, to form this. Okay, I hope you can differentiate. Okay, now I want to ask you, we have learned about, okay, carbocation. What kind of carbocation are these? Okay, this one, Ashley, primary, secondary, or tertiary? Primary, that's secondary. Carbocation, okay, this is the plus. Okay, if this is the plus, okay, you have a look at, okay, the carbon attached to the plus, okay, is attached to how many R group? Okay, this entire thing, okay, is going to be the 1 R group.
Oh, one only. So this
Yeah,
is
so it's primary carbocation. Yeah, primary carbocation. Now, if you look at this situation, okay, this is the positive ion that we are going to look into. Okay, so if you look at that carbon attached to that, okay, they are going to be attached to 1 R group and another R group. Okay, 2 R groups. This is going to be secondary carbocation. Now,
So
R group, yeah, Jonathan.
Does an R group necessarily have to be an alkyl?
Yes, in this case, okay, because in the past I know that R group they can use the H also, but in this case we are talking about alkyl, okay, alkyl group, okay, because the alkyl group is the one that will give you the presence of the carbon is the one that will give you the positive inductive effect. Okay, so when they meant R, okay, in this case it's going to be alkyl groups. Similar for alcohol also. Okay, so the H is not counted as R. Okay, so in this case, okay, it's going to be alkyl. Okay, so here, okay, you are going to have primary carbocation and secondary carbocation. Now, I have taught you about, okay, this carbocation, positive, R group, R group, R group. They have the tendency to donate electron or push electron. When they push the electron, okay, what will happen? The electron will go towards here, and what will happen? They will create a positive inductive effect. Remember the one that I wrote. If there is more support, okay, then you don't commit suicide. Okay, that is actually the positive inductive effect. Okay, so it means that the charges are going to be shared with a lot of people. Okay, so this is going to be more stable. Okay, so tertiary is more stable compared to secondary, compared to primary. Okay, so if you are having something that is more stable, okay, so which one will be formed more? Okay, so this one is very important. You always in chemistry, we always want to form something that is more stable. Okay, so between primary and secondary carbocation over here, Josh, which one do you think will be formed, primary or secondary?
For the second one?
Between primary and secondary, which one will be more stable?
Secondary, because the charge
Yeah.
distribution is more even.
Yes, so this is more stable. Therefore, okay, this will be formed more compared to this. Okay, because why? More positive inductive effect. Okay, it is more stable. You tend to form that carbocation. Okay, once you form this, okay, then you are going to try to follow this mechanism rather than following the other mechanism. Okay, let me put this. Rather than following on the left, you tend to follow this mechanism where, okay, now you are going to have the Br minus come over here and you are going to get this. Okay, therefore, okay, to answer my question, which one will be formed more? This is what we call major product. So you will have more of this, okay, more of this product compared to the product on the left. This is called minor product. And the explanation I have already given to you. Okay, the reason why, okay, you have a major product, because we want something, the carbocation, to be more stable. Okay, in the past, okay, they have this name for this rule. Okay, they call it Markovnikoff rule. Okay, but they have removed it from the syllabus. Okay, but the concept is still there. Okay, the concept is still there. So you just take note. Okay, but the easiest way, okay, of course, rules will be there, concept will be there. So what is there any easiest way to follow? The easiest way is like this: hydrogen always go to the carbon that has more hydrogen. Please remember this. Hydrogen will always go to the carbon that has more hydrogen attached to it. You see here, hydrogen. This carbon has two hydrogen. This carbon directly attached with one hydrogen. Where do they go? They go here. So, major product. Okay. So this is going to be, if you ask me, Mr. Gopi, is there an easy way to remember this? Yeah, easy way is there. Okay, but you still need to explain. Okay, so hydrogen will always go to the carbon that has more hydrogen. So for example, if I want to use this, whatever things that you have learned, okay, hydrogen go to the carbon that has more hydrogen. Let's look at this example. C, then you have CH3, then hydrogen, and then hydrogen. Okay, maybe like this, CH3, CH3. Okay, so I have this, and I'm going to react with HOH. Okay, so what is going to be the major product? Quite simple. The hydrogen must go to the carbon that has more hydrogen to it. This carbon has only one hydrogen directly attached. This carbon don't have any hydrogen directly attached to it. So you just put the hydrogen here. And then the OH will go to the carbon next to it. Okay, I cannot make it more simple than that. Okay, so to explain that, yes, okay, you need to explain that, okay, because the hydrogen goes here. Okay, to explain is going to be, you are going to form CH3 CH3 positive, or you can form if the H came here, then this will become positive. So you compare, okay, for this one, okay, you compare what kind of carbocation is this, okay, the carbocation that we have over here is going to be a tertiary carbocation, okay, and the carbocation here is going to be secondary carbocation only, okay, so the carbocation, okay, here is more stable, okay, compared to the carbocation over here, therefore this product is going to be formed. Okay, so this one I'm just teaching you how to apply in a simple way. Okay, but explanation is still going to be related to carbocation. Okay, and why they are more stable? Yeah, they are going to have tendency to donate electron pair. Okay, therefore they will create a positive inductive effect, and the charges can be shared to more atoms, and that makes the carbocation more stable.